Mr. Lesham is here. We have two more lessons, including this one on calculus. Then we're done. Today's lesson is, I think, pretty chilled. We're not learning anything new. We're just applying it on, JD, you're going to like it, real world problems. Okay, so this is just to prove why calculus is important. Okay, if you're an engineer or any kind of scientist or financial person. Okay, so I'm reading in, it's example 34 on page 125. The volume of water in a tank changes according to the formula V of t equal minus t squared plus 24t plus 6, where t is the time in hours, from the moment the inlet and outlet of the tank was connected to the pump. The volume is measured in liters. The first question they're asking is, how much water is in the tank initially? Now, before we answer that, I think it's good to picture what's going on here. So, if I was to draw this graph, forget about T, V, what kind of graph is it? What shape does it have first? Or is it an exponential? Is it cubic? Is it a parabola? Is it linear? Is it hyperbola? What kind of shape? It's a parabola, right? Because of the square. We don't have cube, it's a square. Now take it further, Simon. You're going to say, because of that minus, we know it is? So it's a sad face, right? Yeah. So it looks like this. Okay? Now, how do I know it starts from 0, 0? That's really the first question I'll answer. How do I know that it starts from 0? Oh, actually, it doesn't start from 0, 0. What am I talking about? Okay? But it's definitely a sad face. Let's say like this. So the first question they're asking me is how much water is in the tank initially. So, okay, we're moving on from like pure cloud maths to real problems here. Okay? So V is the volume of the water in the tank in a specific time. Right? T is not some kind of random X, it's the time. So how much water was there in the beginning? Okay? What is the volume of the water in T equals 0?
6.
6, yeah. That's the, you sub 0 for T, you get 6. So in other words, it starts from 6. Okay?
Initial.
Now, at this point, I mean, this is mathematically right. But does it make sense in what's the volume in minus t, in a negative time? No, there's no negative time. We start this in the beginning, so I can erase this. Now, can I have negative volume? Okay, over here, suddenly we get negative. We can't have negative. Volume is a positive thing, right? We either have water, we don't have water, we don't have minus water. So really, we can truncate, we can hack off these bits. And before we move on to the next question, let's see what happens here. Okay, the volume of the water at the beginning goes up, and then it starts going down. Why does that happen? Okay, I'll read the bit again, and maybe you can give me, not that it really matters mathematically, but I know for some of your brains, you want to understand what's happening here.
Matters,
okay?
Matters.
From the moment, so this shows you the volume of water from the moment the inlet and outlet of the tank was connected to a pump. Let's see if somebody can explain. Okay, so we've got inlet, water goes in and water comes out. In the beginning there was no water. So you're starting to pump water in, that starts going up. Water comes out, but slowly, because there's not much water, right? Oh. As this thing grows, then more and more water comes out. At some point, okay, more water comes out than comes in. So it goes down like this. This is just in case you want to understand, like, why is this doing it like that? Now they're asking, now, this was easy. You didn't need to know calculus to do that. At what rate does the volume of water in a tank change after 6 hours? Okay, so this is, I want to know the rate after 6 hours. And then find the rate after how many? 12, 15. Okay, after 15 hours. So now they're not looking for the level of water. This thing shows you the level of water. Now they're looking for the rate of the water. Is that going in? Yeah, the rate of change. How do you know, how do you calculate rate of change? Gradient, derivative. Rate, brilliant, okay? So rate, Okay? Rate basically means how much water per second, in this case. If I have a displacement time graph, it will be how much displacement per second, in other words, velocity. Okay? So rate is always the first derivative. Okay? Whenever you see rate, you know you need to calculate the derivative, first derivative, which is the gradient. Okay, so we're going to calculate the gradient. What is the gradient? Now we do derivative with respect to t. There's no x. Yeah, minus 2t plus 24. And if I want to know what is the rate at 6 hours, we sub 6. Where do we sub 6? Into here. Into the derivative, not in the to here. Okay? So it's going to be minus 2 times 6 plus 24. What do we get? 12. So in other words, we are still in the phase where the water level goes up. Okay? The amount of water comes in is more than the amount of water comes out. Okay? Let me just check that we got it right. 12, 12. Yes, okay. Now here, because this is like a science question, we got to give units. I will penalize, I'm a science teacher, so I will be quite anal in this case. You can't just write 12. Okay? We got to find out the units. Now, how do you know the units? I didn't write it here, but velocity, it said, was measured in liters. At some point, I imagine it said that it was measured in liters. And the time was in hours, you're right. It did specify that. So the rate will be, what will be the units?
Liters per hour.
Liters per hour. Okay? Right, next they're asking us, what is the rate at 15 hours? How do we do that? Just put 15 now. Again, is this formula of the derivative. So it's going to be minus 2 times 15, which is minus 30, plus 24. Now we're getting minus 6, if I'm right. Okay, minus 6 liters per hour. And we obviously went over to this phase, where now water is coming down, the level is coming down.
But from what you measured minus?
Next thing they're asking us, after how many, after how many hours there will be 50 liters of water in the tank. They want to know when we have 50 liters water in the tank. Okay? So I've got, let's say if this is 6, let's say I have 50 here. I know the graph is pretty horrible. Okay? I want to know what time. By the way, would there be one time or could there be? How do you know there will be one time? It could be 2. Anyway, let's find out. How do I know how much time has passed for there to be 50 liters of water in the tank? What do I have to do? Yes? Great. So here you have to be a bit careful, okay? This is, let's move your rate, okay? This function tells you the volume of water. You see, this is where I think students will get wrong. So you've got 2 functions. You've got the function and the derivative. And now, because we're asking you physics question, we're not just telling calculate the function, calculate the derivative. This is the volume of water, and this also has a physical meaning. This is the rate of change of water in the tank. Okay? So now you've got to be careful what they're asking. They're asking after how many hours there will be 50 liters of water in the tank. So I must say this one, I must say minus t squared plus 24t plus 6 equal to 50. Okay? And what I will do, I want to have a positive, just for the sake of it, I'm going to try and factorize for now, just for fun, because we haven't done it too much. So I'm going to time everything by minus 1, so it will be t squared minus 24t. I must have put that first minus, so it will be minus 44, so it will be plus 44 equals 0. Right? I think. I moved it first, before I actually multiplied by minus, I moved it first, I had minus 44, and now I multiply everything by minus 1. Okay? Now, how do I make 44? I don't know. I don't know. Maybe it doesn't factorize nicely. Let's just peek. No, it does, and my brain didn't work. Okay? So,
22,
say again?
maybe 22 and 2.
That's it. Well done, Ollie. Okay? So 22 and 2, obviously with minus, because we'll multiply, it's still 24, but when you add them, it's minus 24. So I'm getting 2 answers. Okay?
Yeah.
So the answer is either after 2 hours or after 22 hours.
Is it good?
Yes. Okay, exactly. I'm just going to say what you just said. That initially, you see, nobody asked us to draw this, but by drawing it, I already identified that probably I'm going to get two answers. Well, that's not a surprise, because normally with quadratic equation, I get two answers, right? Yeah? But obviously, there could have been a case where maybe I just asked what's the maximum water, and then it will be just one answer, right? Okay, let's see what's the next question. So now they're asking, after how many hours the rate of water, oh, I'll read it exactly. After how many hours will the volume of water decrease? I'm emphasizing decrease at a rate of 12 liters per hour. Okay, what do I substitute and where? First of all, which function am I going to use now? The volume?
Derivative.
The derivative. Because I'm asking, they're asking about the rate. So it's not the first, the second one. See, again, they're asking, after how many hours will the volume of water decrease at the rate? So we're looking at decrease. So I'm going to use the first one, minus 24t plus 24. And what must I make it equal?
Minus 12.
Minus 12, because it's decrease. You see how, this is a classic physics question where in maths we just tell you, make it, when is it equal to minus 12? In physics, we use words and you have to understand that decrease meaning negative gradient. I'll pause here. Thank you, Simon. This is not minus 24t, it was minus 2. Okay? So rate of decrease of 12 meaning equal minus 12, and yes, you gotta use the derivative now, not the function. Quickly rearranging, I'm getting 2t equal to 36, t equal 18. I'm just gonna check out 18 hours, happy days. Okay? Now, I'm gonna ask you a question that they didn't ask here. And they're probably gonna ask it in a second, but I'll ask it now. Yeah. Yeah, they actually asked, so it's the same question. So that's the follow-up example. Let's see how I read their mind. After how many hours, I'll read, after how many hours does the water volume, or the volume of water in the tank, okay, I'm going to rephrase it a bit. Basically, I'm looking for the maximum volume of water. After how many hours did I reach the maximum volume of water? And I'll pause here, let you think. So after how many hours we reach the maximum, or maybe let me just tell you how they phrased it. They said, after how many hours does the volume of water in the tank start decreasing? It's the same thing. I just don't like it. It's quite sloppy what they say. It starts decreasing here. It's reached the maximum. To me, it's better. Then what you guys told me very correctly, that this is a stationary point. So what we're going to do is we're going to make the derivative equal to 0. Or in other words, minus 2t plus 24 equal to 0. In other words, t equal to, can anyone do it in their head?
I would say 12.
12. So after 12 hours, we reach the maximum. Okay? Let me just pause here for a second. Let's just move on with the question. So Ollie said, okay, that's how many hours, okay, passed until we reach the maximum, but we still don't know what was the maximum. That's the next question. You anticipate, you read their mind. The next question is, what is the actual maximum volume? And Simon said, no problem, we'll just put t equal 12 in the first equation, because the first equation tells us how much water we have. So if I sub 12 here, minus 12 squared plus 24 times t, 24 times 12 plus 6, these guys get 150 liters. That's the maximum. Okay? Now, I just want to show you here, it's not something you need to do, but it's just to show you how cool is calculus. Because I could have given you that question without any knowledge of the derivative. Last year, maybe even grade 10, I can't remember. In grade 11, we did definitely ask you maximum, minimum. We gave you this formula and we asked you what was the maximum. Do you remember how you used to do it? Without any derivative, you could have done it. You did it with something called, you probably forgot about that. Completing the square. That was your favorite. Yes, he was a star now. So let's just do it, just for good old time's sake. How would we do it? Okay? So we basically, first of all, put a minus there. t squared minus 24t minus 6. I know at this point, guys, you're very rusty in it. It's no big deal. I'm not trying to remind you how to do it. I'm only showing you how amazing is this calculus, because you see how long it takes this. Okay, then I'm going to put the minus here. Now I'm going to say, okay, this is t minus 12 squared, okay? And then I have to minus 144, which is 12 squared, and then minus 6, okay? All right, then I can say, okay, v of t is equal to minus t minus 12 squared, and then this is minus 150, so plus 150. So after a little bit of work, I completed the square, wrote it like this. And then I can tell you, without any knowledge of derivative, is that the maximum will be at equal t equal 12, and the maximum amount of voltage is actually 150. Now I know I can see JD. JD loves this. Yeah? So he likes it, he smiles, he likes it. But most of us don't really like it so much. See how much easier it is if you just know to find the derivative. You just find the derivative, make it equal to 0, you get t equal 12, you sub and you get 150. I mean, look, it's not longer. I won't say it's longer to do it this way, but it's, to me, it's definitely more difficult. Power of calculus. Great. Let's finish here. Bye-bye.